Day 48, page 1134, nuclear physics. We're trying to find the binding energy per nucleon of helium. Given the mass of helium right here, but this includes the electrons. So lucky for us, we can quickly find the mass of the helium nucleus, because that's an alpha particle right here. Or we could have just simply taken the mass of the helium at the top there and subtracted 2 electrons. You could do that if you had a different element, like if you had oxygen and boron, or oxygen, which is element 8, you'd have to subtract 8 electrons to get the mass of the nucleus, assuming a neutral oxygen. But anyways, here we have the mass of the helium nucleus. All right. Well, the particles that make it up are 2 protons and 2 neutrons. So over here to the right, if I take the mass of 2 protons and 2 neutrons and do the math there, I get this amount of mass total for the individual particles. Well, the actual nucleus, as you see, has that mass, 4.001506 atomic mass units. So there's a mass defect, there's missing mass. That's the energy released when this helium is formed. So we get the mass defect of this much by subtracting those two numbers. That's how much mass is missing, and that's the mass that was converted into energy. Or, in reverse, that would be the energy now we're going to calculate that would take to pull this nucleus apart if we wanted to pull it back apart. So I converted that into kilograms using the conversion from atomic mass units to kilogram. So the mass defect in kilograms is that amount. I'm going to plug that into E equals mc squared. So I take that mass, plug it in right there, multiply by the speed of light squared, and I get a mass defect, an energy, binding energy that would be released when this is formed, or energy that it would take to pull it apart, of that many joules. The problem, though, says you want the binding energy per nucleon. So you'd have to take that answer that I have there circled and divide by 4 to get the binding energy per nucleon, because there's 4 atomic particles, 4 nucleons. And if you need to convert to other units, that's fine, but right now it's in joules. Just divide by 4 and you should have it.